When I show people fast Advent of Code solves, the thing they're most often amazed by is the speed of reading. How do they read the problem so fast? And it does seem impossible, but I think it might not actually be as impossible as it appears. For the last video, I looked at screen recordings of the top 3 solvers from that particular puzzle, and they all took about the same amount of time to read the text, which suggests to me that there's in fact a strategy that they're following, and if we can figure that strategy out, we might be able to do something quite similar, at least as far as reading the problem is concerned. So I wanted to figure out that strategy and put it to the test, and so alongside my streaming the 2024 problems on Twitch, I've also been recording myself trying to speed solve some of the previous year's problems. I would open up a previous year's problem I'd never seen before to see if I could solve it in a leaderboard caliber time. Did I do it? Well, you're about to find out. But before we get into that, let's look at how I believe they read the problems so fast. And also, I'm coming to you from my Advent of Code base in a famous nightclub district of East London. So if the sound is bad or you notice I'm actually using a lav mic on a fork rather than the top tier Blue Yeti I usually use, then please forgive all of the video editing and sound editing sins I have committed in the name of this video. Try to bear with me on that. So one approach to reading the problem is the one we all take, feeding the text into your brain, constructing a model of the problem in your mind, and eventually get to the part where it asks you specifically what to compute. If you've ever gotten the feeling while reading Advent of Code of, okay, I get it, grid, steps, whatever, but what is the actual question? Then you're taking this incremental forward pass approach. Fast solvers don't take this approach, at least not for early day problems. You can tell this because they immediately jump to the end. What's at the end? Well, the question, typically highlighted in a glowing text. So they start by reading this question phrase. What do you get if you add up all of the results of the multiplications? Let's imagine this was the only thing you know about the problem. What questions would you then have? Probably something like, where are these multiplications coming from? We then scan backwards through the text to try to answer this question. We notice that the example highlights some things that look like functions, so it seems like they're embedded within this long string. We could stop here and take a guess that no other requirements are important, but if we have any uncertainty about the format of the instructions, we can scan upwards to catch these additional clarifications. Once we're satisfied that we've probably caught all of the requirements, we consider the problem understood. We can summarize the problem as, find all the instructions matching this pattern in the string, extract the numbers, multiply them, and sum. Then we start coding. All of the rest of the text that we didn't read is time saved. You might be thinking, well, sometimes you're going to miss a detail, and that's absolutely true. In fact, you'll see me do that a number of times in this video. It's just a trade-off you make if you want to go fast that you catch enough of the important details enough of the time. The alternative would be to pay the time cost of reading carefully on every single problem, even when it wasn't necessary, and that's just going to be slower most of the time, which isn't ideal. Let's give it a try here. I'm going to flash up on the screen an early Advent of Code problem from a few years back, and I'll give you some time to extract all the important information. You might want a full screen now, and sorry if you're watching this on a small screen, it's essentially going to be impossible for you to do this, but you can give it a go anyway if you like. I'll also pinpoint where the last line of the problem is with this arrow so that you can point your eyes there. We'll start with 10 seconds, which I think is going to feel like a lot of time. Let's go. Alright, take a moment to get the answer straight in your head and then I'll tell you what it is. In this problem you get a list of numbers, you have to find the two that sum to 2020 and then multiply them together. Assuming that you're okay at reading English and you don't have dyslexia and your screen is big enough, I imagine you found that fairly easy. This one was actually so easy that it possibly contributed towards overloading the Advent of Code servers, as we'll see later. Let's do another one. I'm going to give you 7 seconds for this one, plus it's just slightly more difficult. Okay, take a moment to get the answer straight in your head, and then I'll tell you what it is. The problem is you have a list of rows which are themselves lists of numbers. For each row you find the difference between the largest and smallest value. You sum up those differences and that's your answer. Let's do one more and crank up the challenge level just a bit. I'm going to cut off the start of this one just to make it a bit easier to read as well. 5 seconds. Let's go. Got it? For this puzzle you have a grid. Embedded in the grid there are some numbers and some symbols. Your job is to find all of the numbers which are adjacent to symbols in the grid and sum them. There are two requirements that you may or may not have missed. Firstly, the numbers are multiple digit numbers, not just single digits, so you'll need to look around the whole, perhaps 3-digit number. Secondly, adjacent means above, below, to the left or right, and also diagonal. If you didn't get that last one fully, don't worry too much. It may be your first try and you weren't really in control anyway, so you can definitely improve on that. If you're interested in reading a competitive programmer's account of how this process works, there's a great blog post by a Canadian called Kevin Yap, which I'll link below. It's me again, with the fork. I decided to put this to the test by finding problems that I'd not done before, opening them up as if they'd just been released, trying to solve them as fast as possible, and then if my time was lower than one on the leaderboard, it would count at least as a sort of time travel leaderboard time. I wanted to do this because I think competitive programming often feels a little bit out of reach. Like if you're not going to be one of the best in the world at it, it's really not worth attempting. But we wouldn't say this about other puzzles, games, or sports. We would say that you can have quite a lot of fun with those things even if you're not top of the world. So I wanted to find a way to show you that you can still have a lot of fun with this hobby without having to be best in the world at it. The second reason I wanted to do this is because I think competitive programming probably seems a lot harder than it really is. And you'll see in the course of this video, you can get some decent results just with some time and practice. So I wanted to show you that as well. It's not big brain, unattainable stuff. This is just doing something you already do quite a bit faster. All of this is contingent on the fact that I actually make some progress here, so let's see how I did. I decided to copy a lot of Alex's approach from the last video and create a utility library based on JavaScript prototypes so you can solve a lot of problems with chaining. I decided to use the dev tools as well because I thought that was a great place to start with solving these things, so I do move into the editor a bit later on. One of the neat things about having your own utility library is that you can sort of write it to match what comes out of your own brain. So if you're like me and you keep misspelling seal with IE or EI, I can't never remember which, you can just have an alias for both and then not worry about it. Anyway, so I started working through the first sort of 1 to 4 problems of each year, working backwards from the present, skipping of course years that I'd already done. Let's take a look at my first attempt. I went through a few versions of my setup for this, so please forgive any small text and I'll try to compensate with some voiceover where it's helpful. After a bit of setup, I first tackled 2021 Day 2. Okay. As we go through, you'll also see some dots at the top of the screen, which will show you the leaderboard as it evolves. Purple dots are for part 1 and golden dots are for both parts. I've also done some sound effects and it's my first time of doing that, so I guess enjoy that. Okay. It's going to be the uppercase. Okay, if it's forward, we increase the horizontal position. Okay. I think that will work. We'll see anyway. So this is going to be H pause, this is going to be D pause, we're going to increase it, and then here we're going to go down, up. Okay, we got nans. Okay. Let's see if we get any better with that. Nope. Forward, down, up. It's not going particularly well so far. While everyone else is already on part 2, I'm messing around with nans under, I think, the belief that my utility library does something that it actually doesn't do. I spend a bunch of time debugging and eventually lose out to that. The interesting thing is that for reading the problem and coming up with a basic working logical solution, I wasn't obviously too slow here. My execution, the actual programming part, was the issue, and this may become a theme. Let's look at the next one, 2021, Day 3. Power consumption, the subroutine. Most common bit in the position.
Right, so we've got the most common bit in every position. Okay, fine. Okay, now we want to map over that and get the is this what I wrote? Unclear. Okay, that looks suspiciously incorrect. Most common bit. Oh, it's always coming out as 1. Why is it coming out as 1 always? That shouldn't be right. Oh. Just silly mistakes. Okay. We want to join. Can we do this? Yes, we can. And then we want to pass into this with 2. We get this. That's not the right answer. Okay, let's try this with the trial. $22. So that's correct. We've just got it wrong on the wrong here for some reason. No, wait. That's the gamma rate. Something else. Gamma rate by the epsilon rate. Epsilon is calculated a similar way. Most common, least common bit. Okay, fine. Fine. Okay. So that's that. This is going to be 1, which means we need to pass this multiplied by this. Gosh, there's a lot to read. Okay, great. Part 2. Life support rating in the submarine, which is multiply oxygen generator by CO2 scrubber rating. Oxygen generation rating is
This is a really interesting advent of code problem. The thing that should shock you, and shocks me, is that I've gotten the first star before anyone has gotten both stars. That's in part because this is a reading heavy problem with lots of details in it. That's what makes it difficult, extracting all of the rules from the text in a short time. Still, the leaderboard gradually fills up while I'm muddling around trying to get all the rules right, and I'm nowhere near a leaderboard time for this. Let's take a look at my next attempt, which is day 4, 2021.
okay. What will your final score be if you choose that board? Score of the winning board can now be calculated. Board wins because it has at least 1 complete row or column of marked numbers. Numbers are marked. Okay, fine. It's a bingo game. Fine. Okay. 1 complete row or column. Start by finding the score of all unmarked numbers on that board. Okay, so what we've got to do is work out which board wins and then identify all of the unmarked numbers and then multiply that by the number that was just caught when the board won. Okay, this is a real This is a real month, a real year for it, isn't it? Okay. I don't think I'm going to get this one, but let's give it a go. So we got some boards. Is this even worth attempting? It's always worth attempting, Kay. It's always worth attempting to see if you can make it better. Okay. No. No. You're really gonna do that to me?
Of course, while I admire my own determination in tackling this one under the timer, I did not get a good time. My utility library had nothing in it to really help with this because I was optimizing for simpler problems because I thought that would maximize my chances. Still, it's interesting to see the leaderboards also filling up more slowly too. You can also probably hear I'm getting frustrated, so I call it a day, which means you get to benefit from my slightly better setup on the next day I attempted this. I go back a year and tackle day 1 2020. If you happen to be watching this and you attempted to get onto the leaderboard on day 1 2020, you will know what is about to happen. I'll let the rest of you try and make sense of it as you see it.
Okay. Two entries. Okay. We want to go through each pair, right? They're not adjacent entries. Okay, so we need to go through each one. $2020. Okay, you want to go? We've got nothing there. Fine, let's try it again. Oh, yeah, they are. They should sum. They should sum. What have I got wrong here? Yeah, that's definitely wrong. Yeah, okay, not flat map. Yeah, this is the flat map, right? Yes. And then we want to take this approach still. Okay, and then we've got these two, which are the same, 618 times 1402. That's that. That's part one. Part two. What is the product of the three entries that sum to 2020? Fine. Okay, we just want to do this again. Are we going to get lucky on having this be relatively easy or not? Maybe not. Okay, what do we got? Okay, 928 times 547 times 545 is this number, and we get that. Come on. Correct. Okay. What was that time? That looked like a pretty easy problem, so I think I probably got that a little out of the leaderboard. We'll look at the recording though. Actually, how long have we been going for? 3:32. What does the leaderboard look like for this problem? Very high. Very high. Have I got this? I've got this wrong in some way. That's weird. Why is it so high?
It's so high because Advent of Code actually had an outage when this problem was released. Of course, outages have many factors, but I do wonder if because this problem was comparatively so easy, the traffic for answers all spiked at once, and that exacerbated the problem. In any case, if you want a leaderboard caliber time, Day 1 2020 is a great day to attempt. Let's take a look at the next one, Day 2 2020.
Okay, good. How many passwords are valid? Passwords are valid. Yeah, 1 to 3 A's, 1 to 3 B's, and we've got that. Fine. Okay. Great. Right. Map this to the okay, let's go with D plus brackets to the length. Then it's a letter, colon, and then the password. Okay, what do we get for this? Okay, I need to have some more groups. Good. Okay, we're getting somewhere, I think. Right. Nope, that thing never works. All right, let's go with
Another failure, I'm afraid. I spend too much time working with the input and then waste the rest of the time on various indexing issues. This is the real theme and my main take from this exercise. Reading the problem is fine. If you're a typical reader, you'll learn to skim. Identifying the solution, at least in the early days, is broadly okay. A strong utility library combined with a strong execution and minimal mistakes is what makes the champion, at least for the early day problems. I tried Day 3 2020 and make no particular progress, so I keep working backwards through the years, trying the early day problems. Next was 2019, Day 1, and this was where things started to get exciting.
some of the fuel requirements. Fuel required is based on its mass. Take its mass, divide by 3, round down, and subtract 2. All right. Okay. Take its mass, divide by 3, floor it, and subtract 2. Too high.
My mistake here is a simple typo. Instead of subtracting 2, I'm subtracting 1, hence the wrong answer. But my time is still solid. Let's see if I can somehow notice this and pull it back.
Oh, we need to sum. No, wait. Divide by 3 and round down to get 4 and subtract 2. Oh, typo. That's so annoying. That's so annoying. Almost. 21. Nine, 8, 7, 6.
But by this point, it doesn't matter. The Part 1 leaderboard is full, and in Part 2 I'm just rushing and blundering around looking for something that will work. I end up way off of both parts leaderboard time. It's really gutting. This is absolutely the best I've done up to this point, and maybe still is. A simple typo meant the difference between the leaderboard time and nothing at all. But, like I said, execution. I started to feel like a real sports person here. Losing a prize that I felt I deserved due to my skill, just due to a simple mistake, well, that's the reality. You just have to not make mistakes. When choosing the next problem, I actually already did the early day problems for 2018. back in 2018. So I'd skip back another year to 2017, day 1.
Solution to the captcha. Find the sum of all digits that match the next in the list. Too low. What could be wrong? Oh, it's cyclical. Right, so it will be one above. No, it's not. No, it'll be 2 above. It'll be 3 above. Oh, screwed again. Part 2. What's the solution to new captcha? Let it consider the next digit. Want to consider the digit halfway round the circular list. Sum if the digit... Okay, right. Forward. Okay. Divided by 2 modulo its length. $10.76. Let's try it with that. Okay. That wasn't so bad. How did we do?
You did pretty well. That's a leaderboard time for both part 1 and part 2. Kind of. You see, I hadn't quite realised this at the time, but of course as you go back in time, Advent of Code is less competitive, it's less well known, and so people aren't as experienced in the problems. So yes, if I time travel back to 2017, then this would definitely be a leaderboard time, but it's not as impressive as a 2024 leaderboard time. You can see this, I think, in the fact my execution wasn't miles better than the last example, and the leaderboard is filling up quite a bit slower. I think 2017 is really the first year that it was properly competitive in the same ballpark as what we see today. It's still quite soft, but for 2016 and 2015, it's really soft. So call this a teenage year. For good measure, I also did 2017 day 2, where I also placed on the leaderboard, plus my execution was a bit stronger and I felt a little bit more like I'd earned it. I'd still like to tackle some 2019 leaderboard problems, but this video is long enough without that. So I did it. Sort of, at least in 2017. 2024 is significantly more competitive, especially now with the added factor of LLMs, which some people are using against the rules to actually solve the problems, and some people I think are probably using just to sharpen their skills, which has also added to some of the competitiveness. Still, my aim was to show you that you can have quite a lot of fun and make quite a lot of improvement with competitive programming, and that these leaderboard times are not so out of reach that you need to count yourself out before even trying. In a few days of work, I got up to a level which was top 100 maybe 7 years ago, and I think if you put in a bit more effort or talent or both, you might well do a lot better. And this, like every ODES video, has a page on the ODES website with resources and exercises so you can try this yourself. For this video, I've put together a collection of the advent of code problems, sort of 1 to 5 for all the previous years, and the times you would need to beat for part 1 and both parts in order to get a leaderboard time. So you can go there, pick one year you haven't done, open in a new tab, start a timer, and if you come out under the timer, then you'll have a leaderboard time, or a time travel leaderboard time anyway. For ODES members, I've created a little tool which allows you to put in your time and the day and the year and see where you would fall on the leaderboard. Of course, this information is all public anyway, but this is a little convenience to make it a little easier to see where you would fall. The ODES membership is what supports me to make these videos. It's €10, dollars or pounds a month, depending on where you are. And for that, you get extra exercises with each video and other pieces of bonus content like projects and the archive of the Twitch streams of my Advent of Code 2024 solves. And all of this ad-free, of course, as well as my gratitude for enabling me to make these videos. If you want to sign up as a member, then you can go to the ODES website in the description, and various buttons and links will direct you to the right place. Thanks for watching, everyone. Next time, I think we'll probably be talking about problem categorization or maybe problem enjoyment. I'm not quite sure yet. I'll also not be using a fork as a microphone, so look forward to that. Until then, see you later.